Anyway, so our guest is not coming. I went down to a normal class, so I want to show you how to use Metasploit. And I'm following the chapter in the book, more or less, with a few updates, because it has changed some. So it is not slides, I just have a summary of the commands here, and I'll demonstrate them and talk about them. Metasploit should be one of the first tools you use when you're attacking something. The student's getting ready for the pen testing contest in a month. And to get certified, OSCP, Offensive Security Certified Professionals, are practicing with Metasploit. And I think they'll be here on Saturday. They're just going to be doing this all day. They found a device that spins up a whole bunch of vulnerable machines so you can practice. And the first thing you do is do net discover to scan a network quickly and find out what's there. Then you do Nmap to find out what services are running on the target, and then you use Metasploit to attack the services. This should be the first thing you try, and then if all that fails, then you have to try more exotic things. But usually that will get you into a network. This is what H.D. Moore, who wrote Metasploit, calls H.D. Moore's Law. As kind of a joke in the other famous Moore's Law, is that every company, Metasploit will get you in, because somebody did something stupid at that company. They brought in a home device, they installed a game, they forgot to update something, they put on some stupid driver that they brought in on a disk, and if you just scan a whole company network, you will find some machines that Metasploit can just get into in practice. And it's very hard for anybody to be locked down enough to resist this tool. And this is not a very powerful hacking tool, really, because all it does is publicly released exploits. There is a secret version of Metasploit. You have to pay money for it, you have to convince them that you are a legitimate business, and then they give you zeros. So you can scan your network. But the public version of Metasploit, the free version, only has things after they've been patched. So if everybody just put on their patches quickly, they would not be Metasploitable, but that nobody does. I mean, Equifax didn't. They now came out, they did in fact use the struts attack I showed you last time, not the latest one, but the one before it, the one that came out in March. So it was 2 months after it had been patched. Then they tried to blame Apache, and Apache put out an official statement saying, dude, take a hike. When we found a flaw, we patched it in 2 days. What do you want? You just didn't put on a patch. It's not us, it's you not putting on a patch. And of course, the important thing is, to be fair, if you are running Apache struts and server-side Java, then you are probably a huge multinational company with thousands of servers, and it is not a small thing to put on a patch. It is not at all unusual that those companies are 18 months behind on their patches, because the amount of testing required to deploy a patch is enormous. So it's not really fair to say, oh, they're just idiots and they should all be locked up because they don't put in the patch in 2 months. I say, I think you're going to find very few big companies at that scale put in a patch within 2 months. Anyway, so Metasploit, we've been using it a little bit, and let me get it out of here. I'm going to quit this one and make it bigger. Okay, so I've got Kali here. Kali includes Metasploit. If you don't need the very latest attacks, you can just run it. If you want to get the most recent fully approved attacks, you can update with apt-get install Metasploit. Apt-get update and apt-get install, excuse me, just apt update. You don't need to get anymore. And apt install Metasploit will put on the latest version, and it'll have all the officially approved exploits. You can also just start Metasploit like this. If you do this, MSF console, you got to spell it right. You still have to spell it right. Tab completion is my friend. All right. And if you do that, it's going to start. And this is actually starting only part of Metasploit. This is starting it in a limited form. And you can tell, because what I really should have done to start it, as they tell you in your book, is I should have started PostgreSQL first. And the very first time I started it, I'd have to do this thing to initiate a database. And to detect that, there's a, let's see, I think, yeah, there we are, good. There is a command to see the database, like db status or something. You might find it here. Here's the page that I found out about this. Yeah, db status. So I'm running Metasploit, and I can use it. But if I type db status, okay, it will tell me PostgreSQL is the database, but there is no connection. So I'm running it without a database. Now, you can do the kind of homework we're doing in this class, where you set up one virtual machine and attack it and take it over. The whole point of the database is, if you're doing a real pen test, you're not attacking one machine, you're attacking a whole company network with 1,000 machines, 10 servers, virtual machines, stuff all over the place. And it turns out that it is really hard to keep track of everything you've done. you scan everything, you start exploiting everything, and then tomorrow comes and you want to find that one that was 50 machines back. So that's what the database is for. The database gives you this advanced feature of using workspaces and sessions, so it automatically records everything you do, stores them in a way so you can search through them and find out your past things, easily make a summary of all your activities at the end. So for a professional pen test of a large company, this is an important feature. But for just doing one machine at a time, the way we're doing it, you don't really need it. Anyway, that's what this Postgres thing is. So I'm running Metasploit without the database here, and that's fine for my immediate purposes. So if you want to learn your Metasploit commands, you can type help, and it will show you the commands that are available here. Here's the core commands, so-called. You can do things like change the color of things, show the command history, exit with quit, and sessions we're going to use a lot. Some exploits automatically open a session so you can type commands at the target, but others don't, and you're just supposed to know to type sessions to see what sessions are there, and use the sessions command to connect to them. Set you use all the time to set parameters, and you could use unset if you wanted to, but don't ever bother very much. There's also advanced options, which I'll show you in a little while, and here you can kill jobs, and down here is the database commands that are not going to work for us because we're not connected to a database. And there's a thing called creds that will show you the credentials in a database, and that's another thing about the database. As you scan machines and dump hashes and dump passwords, it'll keep track of them all. So when you find a box, you can then easily find let's have all the passwords I got so far and see if one of them will get me in this box. You know, like something you'd want at a large engagement.
So,
yeah.
Would you show the names of like just a cluster of databases, you know, say 30, 40, 50 databases?
Well.
And there's sometimes there are instances of different databases being created.
Well, sure. This is only referring to the database you're running on Kali to store what you do, not the database on the target. Okay. If you do find exploits on the target that dump the contents of a database, then I think that would show up as records here that you stole. But I'm not really sure. I haven't done it. But if you find something like a SQL injection, you can dump all the data from a server, and I am thinking this would probably have some ability to save that data in a searchable form, which is, of course, quite a time saver in a complicated job. We're not doing any complicated pen tests like that, but they do. So if you want to find Metasploit modules, so you scan a target, you find out it's running something like FTP or struts or something in some version, then what do? Well, it depends on if there is an attack that's all ready to go for that version. So you can search online, which is probably your best bet. You can search by anything CVE number, bug track ID, Microsoft bulletin ID numbers, and any string in the text like struts or Java or Apache or Flash, any of those things. So, so if you take a look here and we look for the famous MS-0867, this is probably the most famous exploit from like 5 years ago, back to 2008, because it would take over every Windows machine. It was unpatched for a while and everybody really freaked out. So MS-0867, if you search for that, you'll find nothing. Unfortunately, this is not as friendly as like Google. You have to have a 0. That's their format, which is pretty rude. And then you'll find this thing, relative past stat correction, a few others, a vulnerability service. This turned out to affect all versions of Windows that were in use around 2005 or 8, whenever it was found. It was 2008. It was very scary. There was a Department of Homeland Security alert telling everyone to panic and update your Windows machines, and on it went. But you can see it's really only exploiting machines that are essentially out of use now. 2000 XP and Server 2003. Server 2003, I think, has reached its end of life, and there's a few people paying for extended support, and a few holdouts still using it even after the end of life, which is unwise, but of course people do it sometimes. And XP is out there primarily now in the form of XP embedded in things like ticket machines at the airport and point of sale machines that are really hard to update. And but those have been patched if they have put in any patches since 2008. So that's not asking too much. Anyway, so this used to be the cat's meow, but with the end of XP, this one pretty much reached its end of life. But let's see if we can find it in Metasploit. Now I know the official name. It's got this MS-08-067. Let's search for MS-08-067. That's the form of the string that Metasploit wants to see. And so we should find 1 or 2 versions of it here. There we are. So there's the exploit. This is the path. This is actually the path through the file system to find it. These things, I think, are in something like user share, local share.msf4. There's some home path, and this is the path that leads to the exploit. So this one here, you can learn about it with info. So exploit Windows SMB MSOH67, and a little more detail about what it is. I can do info of that, and it will give me basic information about the exploit. This tells me the full name of it. This is summary, this is useful information. It's a Windows attack only. You can't attack Linux or anything with it. It is great. Great means not only does it always work, it doesn't crash the target, and it automatically attacks many different targets without you having to set the target identity. That's the best. Great or excellent are the big ones up here. So that's why this thing was the cat's meow until it finally went out of date, as Microsoft finally abandoned the really old versions here. So the HD Moore wrote this one. And here's all the targets, and that's the point. Windows 2000, Windows XP, Windows 2003, and that's really it. Just every possible version of those products, which was really, really scary in 2008, and really, really not very scary anymore because almost nobody except complete clowns are still using those old things. And it's not surprising if you're using things that old that you're going to get owned. Now, here's the basic options, and it's not projecting very well up there. Let me drag this to the right a little and see if that helps. Yeah, all right. So our port has a default value. It's required. The pipe has a default value. This has no value, and yet it's required. So the only thing, which is very common, is I have to set the target IP address. So let's try my server target over here. There it is. So here's my Windows 2008 server, 172.16.1.191. In fact, I can actually probably copy and paste between virtual machines, if I'm lucky. Okay. So let's set our host. Tab is not working. Oh, I didn't use it. I just got info about it. Pardon me. You have to use the exploit before you can go setting the parameters. I got info. Use will actually tell it I'm going to use it, and that changes the prompt to that context. Let me move this up on the screen to make it easier to see. All right. Now I'm going to set our host, and tab will complete it, to that number. And now I can do exploit. And it will now send that attack to this poor Windows machine here. And this is what a failure looks like. Fingerprint tells me it's Windows Server 2008. Exploit aborted because it has a list of vulnerable targets, and that is not on the list, so it doesn't try. It says forget it. I cannot exploit that target. This is what you will expect these days with such an old exploit. So that's not a big surprise, but you see how it looks when an exploit fails. All right. Now, here's payloads. And let's take a look at this while we're here. We can do show payloads. Exploits typically have a default payload, which as far as I cannot find any way to see the default payload. On Linux, it's almost always reverse shell meterpreter. On Windows, I think it's the same, but I can't find a statement anywhere or a command that shows you what the default payload is. So if you just run exploit, it'll try to do some default thing to the target, which is usually pretty good. But if you want to see all the options, show payloads will show you all the payloads consistent with this exploit. Not all the payloads in Metasploit in general, but all the ones that work here. Like it's only going to show you Windows attacks here because this is a Windows-only exploit. And here's all the things that you can do with this attack if you find a vulnerable target. And so there's some generic ones, some generic shell ones, and then you get down to the Windows-specific ones. The DIL injections are ones that work by injecting libraries into running code. This is the most common way malware takes over Windows machines. And if you take the exploit development or the malware analysis class here, we go through that in quite a lot more detail. And there are many different versions of DIL inject where you inject various kinds of code into libraries. Then there are ones that just exec, I think, in the command line. It just executes things. There are often PowerShell exploits for modern versions of Windows, but I don't think PowerShell is in Server 2008, so I don't think we're going to see them. Here's one that sets up port knocking for a hidden port. So it'll set up a listening service that only answers if you send a certain pattern of packets to open it to try to conceal itself from administrators that might be looking for it. There's ones that will connect over HTTPS, so all your data is encrypted, and so on. There's many, many versions of ways to get control over that device. All right. All right, so let's, you've seen module options. All right, and you set your attacks or your payloads and then exploit the thing and you will get failure. Now this one here, all right, let me shrink this down a bit so I can see it. This is one that works, but that's because it's not MSO867. So MSO867 has been patched, so I'm going to switch to a different one, MSO8078. This one actually works on server 2008. So let's start with search, MS08078. This is not as important an exploit. It did not affect all versions of Windows. And another important thing about it is the MSO867 works with no user interaction. You can just take over the box when it's just sitting there. This one here requires social engineering. You have to trick the user into going to a web page to use this one. So it is a lot less dangerous. You can't just take over boxes that are just sitting there. And all right, so here it is. There's the name of this thing, MSO8 XML corruption. The XML gives you a clue that it attacks your browser, and the fact that there's browser in the past tells you again, this is only Internet Explorer. So you can see it's a lot less worrisome. People are using Chrome and Firefox. It wouldn't going to hurt them, but it has its purpose. So let's use this one and then get the info about it. Okay. There's parameters. Okay, here's the usual information. Rank is only normal. This one is not great. It doesn't automatically take over the target. The user has to make a mistake. You know, it's not as awesome. It's automatic targeting. At least you don't have to tell it what version of Windows you're attacking. But here's the parameters. Notice I do not have to set any parameters because this does not make a reverse shell where the target phones home. It sets up a malicious web server that is serving up a malicious web page, and anybody that views that page will get owned. So it's going to listen on 0000, which means it will just listen on every interface on this machine. That's the arbitrary IP address on port 8080 and not over SSL. And it's going to fill that with a random, default is random. So I could specify the URI path here to make it easier to type in. And I think I'll do that this time because the random ones are kind of annoying. This module exploits a vulnerability in data finding of Internet Explorer. It uses a DIL injection. And so let me set URI, URL, path, or IPath. All right, what was it? URI path, how rude. Okay, I thought tab completion would work. I'm going to set URI path to games.htm. All right, now I'm just going to hit exploit. I don't need to set any parameters really. I just set that to something to be less annoying. Okay, now my machine is listening on port 8080, serving up something called game.htm. So I have to trick people into visiting that page somehow. So let's visit that page from our vulnerable target in Internet Explorer. Okay, so they don't see anything there, but there it goes. Sending the exploit, sending stage 1, then it sends Meterpreter. Meterpreter is the custom shell that Metasploit likes to give you that has a lot of fun features, more fun than just a normal command shell. And now I'm in. It did not open the shell for me. It tells me session 1 opened, but when I press enter, I'm not talking to the target yet. I'm just talking to Metasploit. This is where you have to know to use sessions. That will show you that I do have a session, a Meterpreter on my Windows target, and to open it, I have to do sessions -I for interact with session 1, because they're thinking you might attack a whole bunch of networks, a whole bunch of machines. You might have 10 or 20 or 100 sessions on various machines, and you have to tell it which one you want to talk to. So now I'm in Meterpreter, and I think it's sysinfo will tell me what I've got. Yeah, that's a Meterpreter command. It is not a Windows command. And so this tells me I'm taking over Windows 2008 machine. And if I do help, here I'll see the Meterpreter commands. And so here's the Meterpreter commands, sorted into groups. Okay, here's the basic commands. Background will put this, when I'm done interacting with this one, if I had another one, I could hit this in the background. Let me do that first. That's probably a good thing to know. So I'm talking to this server, then I get tired of it. I do background. Now I'm back talking to Metasploit. And I could do something else. And then when I want to get back in, I still have the session. I did not end the session. It's still there. So I can get back in the session later. This is what you'll do if you're taking over many machines. You do something on this one, like you find a password on this one, then you say, oh, I want to use that password and try it on another machine, and then when I'm done doing whatever I do there, I want to come back and mess with this machine some more. So that's what you do. So now I'm back here. Okay, let's do the help again and see some of these others. All right, that's what background does. You can kill a background script if you want to. If you decide you don't want it, you can list all the ones that are running and so on as it gets you out. Help and info, GUID gets the session globally unique identifier, which is not that interesting. Migrate is really important. Right now, I have exploited the browser. And look at what the user sees. The user went to some page that was supposed to be a game, and they see this. Now, how long are they going to stare at that before they decide something is wrong and they close it or restart the machine or something like that? If they do that, so suppose this person says, all right, whatever this game is, it's not fun anymore. I'm just going to quit and go do something else. So they try to close their browser, and it looks like, oh boy, doesn't look like it's easy to close your browser because this thing's sort of crashing. There, I can do this maybe. No, that isn't working either. Boy, this really fouling up the machine. This is a pretty nasty exploit. Let's see if I can get a task manager. Oh, good, I can do that. So this is just what I would do if this happened, right? My browser froze, something's wrong with that page. Let's see if I can just end it. And if that doesn't work. This, by the way, I would not assume I'd been hacked at any point here. This is normal Windows operation. As we all know, this happens all the time. Your Windows dies on you for some ungodly reason, your browser freezes up. I'd be right now saying, why in the hell didn't I just use Chrome or Firefox? This is what I get for using a Microsoft product, you know. And so let's go to process and kill the process. That should usually work. Yeah, so now I've killed Explorer, and boy, what a struggle it was. Now I just say, boy, I'm going to install Chrome and never have that problem again. And so that means we just lost our shell. If you go here, session closed, died. So if you don't do something about it, you're not going to have control of that machine for very long with an exploit like this that freezes up the browser. Now, some exploits are cool. They'll show you something in the browser, like you really see your Gmail or something, so you think everything is fine. But a lot of them just freeze and crash up something on the other machine. So what you ought to be doing is migrating. So let's exploit it again. I think the exploit is still running. Remember I said all the machines that visit that web page are going to get owned. So I think I can re-exploit the same machine by visiting that web page again, although I have to get the URL, which is in my shell here, way back up here someplace. All I really need is the IP address. Okay, this is where I'm kind of glad that I changed the name to something I can remember instead of just 10 random characters. So it's 172.191, and then 8080. Okay, and then it was /game.htm, I think. And let's see if that does it. Not yet. Okay. I think I'll just run the exploit again. Okay. Handler can't bind. Okay, let's exit. Well, maybe I'll solve this problem. See, the problem is I have another handler already running on 4444. But I'm just going to make another one. I'm going to change it to another port since I've somehow lost track of what I'm doing here. Let's show options. It's L port. So all I have to do is set L port to 4445. There, now I can do another exploit. And game is already added, server stopped, started reverse handler. Looks kind of evil. I'm going to leave and come back to clean up my Metasploit. Okay. All right, now I'm going to search for MS08-078, which will get me the attack I want to use. Yes. Okay, so there it is. Use it. And I know I don't need to set any parameters. I'll just run the exploit. It'll choose a random name, and I don't really care. Okay, so there's my random URL. So people that visit that should get owned. So let's see what happens if I do that. All right, that looks like it should. There we go. So now I got another session open. Okay, so it's sessions minus I1 and help, and we're back on the road to talk about these options. So now, as I said, I am currently in that browser, which the user is probably going to close pretty soon, so I want to migrate to a different place. Now, here's my commands. The migrate is how you move, but in order to migrate, I need a process ID. So I need to list processes, and that'll be down here. Here's the file system, here's networking, here's system commands, and it's PS. PS will list running processes. This is just like Task Manager. So if I do PS, it shows me all the running processes, and there's too many of them, but it will let me use grep. I can pipe it to grep and choose EXP, for example. It will show me just the processes that contain the string EXP. This is Internet Explorer. That's where I am right now. And I don't want to stay there because I know the user is going to close Internet Explorer pretty soon. This is Windows Explorer, which is the process that draws the desktop and the start button. It starts as soon as you log in and continues until you log out. That's a much better thing to be in. So I want to go into that process. So I'm currently in 2028 PID, and I want to move over to 492. So I just migrate to 492. That takes the code that's running and moves it into a different process. So now I've done that successfully. So now supposedly I can close the browser here and survive that. And in fact, it looked like when I moved, it closed the browser. So the browser will crash and close. The user doesn't have to go to Task Manager and all that garbage. This will just look like normal life with Windows. And now I still have control of the box. So that's one thing to show you. Then you've got, you can, of course, list files. You can send files up to the box. You can pull files down from the box. You can print your working directories and move things up. You can also set up networking, display your interfaces. And here's the other things I typically like to do. You can clear the event log, so you remove the traces of what you just did. This is why you'll see in CCDC, one of the injects you typically have to do is, the defense competition, is to set up remote logging. What you should be doing is exporting the logs from your devices to some central server, so that even if some evil criminal erases the logs, they will be somewhere else already. Just like if you set up a monitoring camera in your house, the burglar will just go in and steal the camera, and what good did that do? You have to be saving the data out of the house. Anyway, so that's the game here. I could clear the event log. I can find out who I am with get UID. And I find out that I'm administrator. And then I can turn on the webcam and the microphone. If it's a home device, I can do that sort of thing. I can steal the keystrokes with key scan dump or the screenshot so I can see what's there. I can list the desktops if there's more than one. Anyway, then another fun one is hash dump. Hash dump will dump out the Windows password hashes. These are the hashes. This is the name of the user. This is the user ID, 500 for administrator. This is the LM hash, the old IBM format that's very miserable, and that is no longer used by any supported version of Windows. You'll see it's always just AAD. This is just a placeholder, which contains no information, just so that it's compatible with the format, but it's not used unless you turn it on, and you'd have to be nuts to turn it on. What's now currently used is the 1993 era NTLM hash, which is one round of MD4, which is appalling, 100 million times weaker than Linux hashes, but it's probably a million times stronger than that one. So this one you could crack in the 70s and the 80s. This one you can crack pretty easily these days, but anyway, that's a hash. So you can't just read the password right out, you have a hash, and if they actually choose something like a 12 or 14 character random password, then you probably can't crack it at any time soon. The only thing you can find is maybe the top 100 or top 1 billion passwords. Those are going to be in a list, you can look them up. Anyway, those are hashes. But suppose I want more. To get more, I have to go outside of Metasploit and add another feature. So we migrated, you can do screenshot and all that jazz, which you've done in the other class, and I can get UID, find out who I am, and I can get password hashes, which I would then have to crack, although sometimes you can just pass them to another server and pass the hash attacks without cracking them. But if I want to get the real password, I can use Mimikatz. Load Mimikatz. This is fantastic stuff written by a guy in New Zealand who talks at DEF CON all the time. He's Gentle Kiwi, I think, on Twitter. He's awesome. He keeps on humiliating Microsoft every time. He totally understands Microsoft Kerberos, and he knows how to do horrible things. Like he can get a golden ticket. Kerberos is an MIT system to avoid sending passwords over the network. So instead of sending your password up to a server, you request to use a server, and the server decides to let you in. It gives you a ticket, which is only good for 10 hours to access one service. And it has a ticket granting service that can issue the tickets, and that is based on a golden ticket. And the golden ticket is the master key that is good for 25 years. And he figured out how to steal the golden ticket, which means I think even if you erase the whole Active Directory database and regenerate it, people can still get in. It's awesome. Anyway, but this is a much simpler thing. I'm going to get the user's current password, which is in memory. So I load Mimikatz, and then I just do Kerberos. Now, normally, in earlier versions of Metasploit, it seemed to me like I had to elevate to system, because you can't do this as administrator. Only system can do it. But now it's automatic, which I thought was pretty cool. Not currently running a system, automatically runs an update to try to elevate the system, and it works. And now I get the plain text password. This is not a hash cracking exercise. Cracking a hash could take hours and graphics cards and a server cluster. The problem is the currently logged in user, Microsoft stores their password in RAM with reversible encryption. And there are two tools I know that can reverse it. Mimikatz is one. Another one is a Windows-based Microsoft tool. Forgot the name, but I used to use it. There's various, it has leaked out. The proprietary secret, the key is hidden somewhere in your RAM, and the encrypted password is hidden somewhere in your RAM. So after you know how to do it, it just fetches a few registry keys and reverses the encryption. All right, so let's see if I missed anything I wanted to show you. That's the basic techniques here. Oh, we got to talk about shells. So we are currently using a reverse shell. Reverse shells is the default. This is usually what you want. So reverse shell means I was able to somehow upload some code and execute it on the server. That was because of the vulnerability in Internet Explorer. You're never going to get it unless you find some kind of vulnerability like that, or you trick the user into running something with like a fake update or something. So when you run the code on the server, what you typically do is you make the target send a signal back to the command and control server saying, please control me. This is because of Windows Firewall. Windows Firewall, by default, lets you make outgoing connections, but you reject all incoming connections because you're running as a client and not a server. So this actually should not be working on servers. And when in the network security monitoring class, we're talking about this, you ought to configure your servers so that they can only receive connections. They cannot initiate things. Your administrator should not be on your web server opening Internet Explorer, downloading a driver. This is a poor practice. Your server should never initiate a connection somewhere else. If you want to put something on it, you should go to another machine, download it, bring it in on a USB stick or something. Then you'd be safe. You could configure a firewall not to allow your server to make a connection to a remote host, but they're typically not that way. Certainly Windows clients are the other way. You can connect anything you want, but nothing else can connect to you. So anyway, that's all the reverse shell. Reverse shell is the most commonly what you want, where the target asks to be controlled, initiating the session on the inside. The other choice is a bind shell. A bind shell will start a listening process on the target. It will then be listening on a port, and then you connect to that port from the outside. This almost never works because you have to listen on a port that's not already in use. You can't have two processes bound at the same port. And everybody for decades has known that you should have a firewall and you should block all the ports you're not using. So if you're using 80 and 25 and 443, everything else should be blocked by a firewall. So even if I run malware listening on 4444, I can't get to it. So only complete losers will fall for this. This is people that just don't have a firewall at all or have totally set it up wrong. And of course that happens, but that's not very common because that's pretty understood. So usually end up with reverse shells. Anyway, so you can set the payload to what you want. It'll have a default payload, but you can set it to something. So let's try a different payload here. This is a interpreter payload that we have right now. Let's set it to just a plain reverse shell to show you the difference. There it is. So I'll get back to my target. Okay, first I'm going to get out of this session. Okay, and now I think it's gone because I used exit. Now there are no more active sessions. So let's try a different target. Reverse TCP. I'll show the options. It is the same as before. I need a listening. Notice I need two sets of options here. I'm going to shrink this a little bit to make it line up better. Okay. I need two sets of IP addresses. This is the local host to listen on. That's going to be 0000 and say 8080. So that's my local port listening. Now I'm going to have a problem because remember my exploit starts a web server listening on 8080. I think I'm going to need to change that port to make it work. Here's at the other end, in the reverse TCP, oh I see, pardon me. This is for the MSO867. This is the server that's going to be hosting up the malicious web page. This is going to be the handler, which is my command and control server that it's going to phone home to. So is that clear? There's two things going on in my server. It's a web server, and it's also a command and control server. And those are listening on different ports. The web page goes out on 8080, and the command and control signals go out on port 4444, and that's on my Linux box. So I'm going to send malware to the target and run it, and that malware has to know the IP address to phone home to. So this IP address is the IP address of my Kali box, not the target. Because this is a social engineering attack, I do not have to specify the identity of the target. Instead, I have to trick the target into somehow running this malware. So if I run this one, I don't need to set any parameters at all. And the already in use or unavailable. I've seen that happen before. Let's just change L port to 4445 and see if that's enough to make it happy. And it is. So now I have another URL to go to. This is the part. This is why I do not need to fill in the IP address, because the IP address will be filled in by the user who is foolish enough to view this page. So I send them an email or something and trick them into viewing that page. And then, see if I can somehow get back to my other machine. What's going on here? Window Kali. Come on, window Kali. All right, there we are. So now I've got a session open. Session 2, because there was a session 1. So session 2 is opened. And if I press enter, I don't have it. I have to do the same thing, sessions. But this is a shell, not a meterpreter shell. So I do sessions minus I2. And here I just get a standard Windows command prompt. Now commands work like who am I, and IP config, and all that good stuff. This is just a normal Windows command shell. It's not a meterpreter shell, because I chose to use a different attack. All right. The meterpreter shell, by the way, will usually set off antivirus. Of course, it's a well-known attack. So anyway, and there are antivirus evasion options in Metasploit also, but most of them do not evade antivirus because they're public, so the antivirus engines know to watch for them too. And there's always a series of paste bin dumps and blog posts by people with the latest trick to get past antivirus. And every few months, the antivirus people wise up and you have to have another one of them. There are Russian forums where for 30 bucks they will write you a custom encoder, which is pretty easy to do anyway. Anyway, so that's the game there. Your book mentions MSF CLI, so you can do commands all from one line. So if you had a command you wanted to execute, you could just have one command that will make the shell and do everything. Now it's just part of MSF console. You do it with -Q, which is quiet, and -X. So it will then do this attack and exploit. You can give it a series of commands so it'll all happen from one command. This might be appropriate if you're scripting something, you want to run this attack. For example, if you just want to test for a vulnerability, you want to try this attack on every box and then record how many I got in. Something like that. All right. You can make standalone payloads. I know you did this back in 123. This is how you make malware with MSF VENOM. MSF VENOM uses the same database of attacks, but instead of doing it live, it creates files which you can then trick people into running. And you can do it various ways. So if you use MSF VENOM, which is here, you can just type MSF VENOM -H for the help, and it will show you what you've got. And the first thing you have to do is find a payload. This will create malware. So you can list payloads with MSF VENOM -L payloads. And the only problem is, with a lot of Metasploit things, there are way too many of them, like 300. So This will take a look at, there they are, all the payloads in the world, page after page after page of them, which is not exactly a useful way to get information. But since this is command line Unix, you can filter them. So you can pipe it to grep. So if I want Windows Meterpreter reverse, if you're smart, you could use egrep and parentheses and ors or something, but if you're just a slob like me, you just grep, because it works. It's totally inelegant, but it will get the job done, and I can always remember how to do it. So anyway, that's going to find things that contain payloads and Windows, like Windows Meterpreter and reverse all in a line, and that should be a shorter list of reverse shells using Meterpreter on Windows. And there's still a few of them, about 2 screens full of them. So here's some kind of hop that does some kind of stage thing with DILs. Here's the plain old reverse this uses HTTP, this goes through a proxy, this uses IP version 6, you know, many, many ways to solve your different requirements. You know, your network might only let certain kinds of traffic out and so on. They're all doing the same thing, but they're sending different kinds of data back. They're all different options available. All right, once you've chosen an attack, you then have to choose an output format. So you can use help formats to see what the choices are. You can put them in various formats, but usually what you want is an exe file. So that's -fexe. So now I can do an interpreter reverse TCP and turn it into an executable file. But remember, I have to specify some parameters. And the one parameter I always need to put in is the command and control IP address. Because when it runs the malware, it has to know who to phone home to. So you have to fill in this lhost parameter. And if I do it this way, it's just going to spew the code right out on the screen, which is unprintable and kind of ugly. You need to tell it where to put the code, like fun.exe. That will create a Windows executable, which when run, will run that code and target that command and control center. Now, if you send this to somebody and they run it, you won't get anything because you have to run the command and control server. And MSF payload does not do that. MSF payload does not perform an attack, it makes malware. So now you've got fun.exe, and you have to somehow get the person to run that file, email it to them, or put it on a web server and trick them into downloading it, or tell them it's an update or something. And then you have to run the multi-handler. You use multi-handler, you define the payload, and then you run it. And this is what you did in, I think, Project 4 in the 123 class. This will start a handler. When people run the malware, they'll then control, and then you have a Metasploit session or whatever you told it to make. So it's just a thing to know. If you do this, if you were using Metasploit in the interactive mode, it would automatically launch the handler and you wouldn't even have to think about it. If you make malware, which you send separately, then it's your responsibility to run the handler, so there's a command and control server to send back to. And when I'm doing this in like capture the flag competitions, another consideration is you can't be behind NAT if you're running a server, so this is why it's good to have cloud servers. Often I run exploits on targets I'm taking over, and I have to use my real cloud servers, like attack servers that are public IPs, so I can command and control my bots. So, you know, be aware that in what we're doing with local copies of VMware and NAT networking is just for testing on one box. But if you're actually going to exploit a machine somewhere else, you really have to have public IPs. All right. Now there are a few other things worth mentioning, although I'm not going to go through in much detail. There's more stuff Metasploit can do. Metasploit is like Wireshark. It's got a community of users that just keep writing more and more stuff for it. So there are scanners. There's a bunch of them. There are scanners that will search for certain vulnerabilities, like whatever's hot. And so they appear here as use auxiliary modules, scanner, that will just scan a network to see if you have certain vulnerabilities. I remember I've done this when big ones came out. You could load it, and then Nmap has them too. You can scan a whole network and see who has the vulnerability on there. This will give you servers that have the directory listing turned on, so you can just see all the files on them, a common mistake. There's one that will scan, here's some kind of WebDAV vulnerability, a Unicloud vulnerability in WebDAV, which is a Microsoft product to share folders. This will query the Wayback Machine to look for old information about your target for reconnaissance. And this is something you may have heard, real professional developers spend 80% of their time planning before they write a line of code, making a block diagram, considering what they're going to do, and then when they write code, they've decided what they're going to do first. And professional penetration testers spend most of their time doing recon, finding out what's there before they start attacking. A beginner's mistake is to just jump right on the machine and do the attack. You probably would have done a lot better to actually, Google the company, Google the people that work there, check these other archives to find out what's going on, or you will find out you attacked something and got in, but you didn't attack the all-important thing that you didn't know about. Anyway, that's the game here. And there's many other things here that will do various kinds of scanning to find things. And then here's the auxiliary reference. So there's scanners, administrator modules, and so on. There's a variety of extra things here to attack certain kinds of things, like SMTP and MySQL and so on. So there's a lot of other things you can do at Metasploit other than just take over box and pop shells. And we're not going to go, I think, any more deeply into them, but there is a whole book just in Metasploit. And it's cool. I don't think there's a certification just in Metasploit, but there probably will be pretty soon if there isn't. Anyway, you should know at least how to do the basic things at Metasploit and be aware that there's lots more. All right. So I think that's it, and all I want to do is a Kahoot. And then I'll go to the lab and help people that want to work on things. Okay, 101-731 is the Kahoot name. 101-731 for the remote viewers. Okay. So what utility makes standalone payloads? All right, MSF VENOM is correct. All right, what's wrong with this Windows shell bind TCP payload? All right, that's it. It's a bind shell, so a firewall will stop it. Only people who don't have a firewall will fall for that. Reverse shells are what you usually have to use. All right, what's multi-handler for? All right, it runs your command and control server, the least popular answer. That's what it does. That's what you launch before you launch a reverse shell so that you're listening when it phones home to the command and control center. It sounds like exploiting many things at once, but that's not what it is. It's a multi-handler because you can have many bots calling to the same command and control server. Anyway, all right. So what's PostgreSQL for? That's it. It records what you did in a database for your report at the end. All right.
Seriously?
How do you make a session persist even after the user closes the target you exploited?
Oh, wait.
Okay, you migrate to Explorer. You could migrate to iExplorer, but that's Internet Explorer, and they might close that. Migrating to Explorer is the best because they won't close that until they log out. All right. What module shows you a plain text password? All right, and that's Mimi Cats. Good, a popular answer. Can't see how many for some reason, but such is life. All right.
These here are the same.
What's that?
These here are the same thing.
Oh yeah, well, good thing it's wrong. Good thing it's wrong. Whoever wrote these things should get a pay cut. All right, so I'll take the top 3, which is Dude, Kokeshi, and Tip Tip. Any questions about anything? So I'll go to the lab and help anybody who wants help tonight. And next week is when things start being due. So next week, a couple of quizzes are due and some projects, so you should be moving ahead on those things. All right, I'll just clean up and go to the lab.